how to set up a secure private Docker registry using Docker Machine and Compose. Let's take a look at a high level of what we are going to go through in this video. Start with setting up a VM on a cloud as a Docker host using Docker Machine, and this VM will have a public IP address. And we are going to be using DigitalOcean as the cloud provider. You can use any other cloud hosting solutions out there. Run Nginx on a container on port 80, and port 80 will be available to the host as well. Create a domain name and point it to the public IP address of the VM that we created. Run registry service on another container as the same host has Nginx, and then have Nginx reverse proxy. Configure SSL on Nginx with a certificate issued by a trusted certificate authority. Enable basic authentication on Nginx so that the private registry is accessed only by authorized users. And the last step is to test and manage repositories on the private registry using the commands such as docker push and docker pull to create, access images on the private registry. So let's get started. Log into DigitalOcean portal. I have a couple of droplets in this account. Idea is to set up a private registry on a new droplet using Docker Machine, so for which I will need an API access token. So go to API, generate a new token, give it a name for reference as Docker Reg, and the token will have write permission, and submit. Now I have a new token generated. Copy the token and save it for later use. Go to terminal on local, create a project directory where I will save the setups and config files that's needed. That is home directory /project/private registry in my work directory. Keep that directory open in an editor. In my case, it is Sublime editor. Back to the terminal, let's create a Docker machine using DigitalOcean driver, which will spin off a new droplet on DigitalOcean. Now the command is docker machine create, driver is DigitalOcean, using the access token which I generated earlier, and a name for this machine. Let's name this as my private registry. Go. After a couple of minutes, it created a droplet as a new Docker machine. Let's go to the DigitalOcean portal and reload the droplets page, and here it is. By default, it created a smallest possible droplet, but one can configure in Docker machine create command things like the RAM, storage, and region where you want the VM to be. Back to the terminal, check the IP address of the new Docker machine, which is same as the public IP of the droplet you see on the portal. As a quick check, let's SSH onto the Docker machine using Docker machine SSH my private registry, the Docker machine name, and that looks good. Exit from the server. Next, I'll set up Nginx service on the server. Create an Nginx config file on my local using Sublime editor. I'll paste in some standard config for Nginx. For this config, Nginx will listen at port 80, and the Nginx document root is user/share/nginx/html, the default standard directory. This is the basic configuration, but we will modify this as we make progress through the next steps. Let's also create an index file with some text. Create a new file and name it as index.html. And the text on the page should be something like, looks good. Now we have two files created in this project directory on my local. Using Docker machine command, let's create a folder on the server for the static files. Let that be /root, which is the home directory, /nginx-root, and scp the only static file we have, index.html, onto that directory. That is copied. Clear the screen and copy the nginx config onto the home folder on the server as well. Now I'll be using Docker Compose to orchestrate Nginx and registry service. So let's create docker compose.yaml. Define a service for Nginx. To make it quicker, I pasted in the service definition, which basically says an image Nginx, the latest version, in the volumes for the Nginx root directory and Nginx config file, both with read-only permission or mode, and port forward 80 on the host to 80 on the container. Before I start the service, let's verify the files on the Docker host. It looks good. Nginx config and directory we created for the Nginx root. Let's change the Docker environment variables on my local to switch to the new host. Verify the Docker host environment variable that it is pointing to the new host on the droplet we created. That all looks good. Now run docker compose up. In a few seconds, it'll spin off Nginx on a container on the server. On a separate terminal window, let's get the IP address of the droplet. You can get it from the portal as well. Using the IP address, access the Nginx on browser. Nginx is running picking up the default index.html from the root, and that looks good. Let's create a domain name to point to the same IP address so that instead of the IP address, we use a readable domain name for our private registry. I have a domain name registered on GoDaddy, and it's called ugni.xyz, cheapest I could get. I will create a domain name of type a record, name the host as mydockerreg so that the domain name for our private registry is mydockerreg.ugni.xyz, and it should point to our server IP address. Optionally, change the TTL value to something like 600 seconds and save. Now let's go to the browser and hit mydockerreg.ugni.xyz, and it works. Now that we have nginx running, let's add registry service and configure nginx as reverse proxy. Back to Docker Compose YAML, add a new service for registry. The image is registry, which is from the Docker Hub, and expose port 5000. Make the nginx service depend on the reg service, and also link reg service. Go to the nginx config on the local and add an upstream docker reg and add server reg 5000 to it. Go to the server section. I'll paste in some code here. This section sets some proxy headers for registry upstream. Save and back to the terminal. Control C on the Docker Compose up session. Check the service status. We have only nginx service running right now. Stop the service. Copy the updated nginx onto the server and run Docker Compose up again. Both the services, nginx and registry, are now running. Now go to the browser and hit the nginx for registry catalog, and the URL is mydockerreg.ugni.xyz/v2/_catalog. Now /v2/_catalog is the resource from the registry service. So it responded with a JSON that has an empty list for repositories. Notice this registry that we created is not on HTTPS or not over SSL. Let's start by creating nginx with SSL. We need an SSL certificate that browsers and Docker hosts or daemons trust. Self-signed certificate is not an option. So I'll generate one from ssl4free.com. Let's enter the domain name of our service and submit. Choose the manual verification option for the domain validation, and that spits out some instructions. We need to follow the instructions, and that is, I need to download the verification file from the link, put that on the nginx on a specific directory path, which then the service will verify and issue the certificate. Now let's download the file. Back to the terminal, I'll create a temp folder to store such temp files. Copy the downloaded verification file into this folder. Let's create a directory under nginx root on the server. It's called .wellknown/acme challenge on the server for the verification file, and SCP the verification file onto that directory. Now let's SSH onto the server and go to the directory where we copied the file. Change the permission so that it is available on nginx over HTTP URL. Exit from the server. Restart the services. Say stop and start. Copy the verification link or hit that URL on the browser and make sure it downloads the verification file from server. Now that looks good. Move forward and download the certificates. Either copy the content from this page or download the files. Private key, CA bundle, and certificate. Let's download them. Create a directory for the certificate files. Copy the downloaded zip file and unzip and delete the zip. Let's concatenate the certificate and bundle. Before that, make sure the certificate.crt file has an extra line at the end. Now concatenate the certificate.crt and CA bundle to generate a server certificate. Name it as server.crt. Create a certs folder on the server and copy the private key and server certificate onto that folder. Private key and the server certificate has been copied now. Back to the compose file, add a new volume for the certs folder under nginx service. Also port forward 4443. Now we need to update the nginx config for SSL. We need to create a new virtual server for 443. Now create one, copy the configuration from other virtual server port 80 and change the listen port to 443. Now this will have SSL turned on and then provide the certificate and private key file paths. Now back to the terminal, stop the services, copy over the updated nginx config and start the services, or maybe Docker Compose up again, and the services are running now. In the browser, hit the HTTPS URL for the registry catalog, and that's working. Cool. Now you can check the certificate details, which should be signed by Let's Encrypt Authority and should be valid for about 3 months. Now let's update the Nginx config one more time to redirect all HTTP connections to HTTPS. Update the server config for 80 to do all the redirects. That's a simple change. Stop the services, copy over the updated Nginx file one more time, and start the services again. Now verify that all the HTTP requests are getting redirected to HTTPS. Now let's add basic authentication on Nginx to make sure only authorized users access our private registry. Stop the service, SSH onto the server, install Apache 2 utils. Now you have several different ways you can generate the password file. So we will use HTTP password tool came with Apache 2 utils to generate a flat file for username and encrypted password list. We're going to start with only one, but you can add more users onto this list. Let's generate one and save that to a file, registry.password. Username is admin and some password. Verify the file is created and it has one admin user and encrypted password. To better organize, I'll create a directory, call it auth, and then move this file into auth directory and change the file name as htpassword. Now exit from the server, copy the password file from server into the local, just so that we have saved that somewhere outside of the server. In local also move this file into auth directory. Back into the compose file under Nginx service, let's add another volume for user passwords file. That is /root auth htpassword that we created on the host to /ets/nginx.htpassword on the container. Now modify the Nginx config file for the basic auth. I'll replace the proxy section here with two blocks to segregate the config for the requests that are registry specific or non-registry, such as static files which can be served off of Nginx directly. Regardless, we'll have a basic auth as a common configuration. Now the two entries, auth basic and auth basic user file, are the key. User file points to the one we added in the volume. Copy over the Nginx config onto the server. Stop the services one more time. Before we run Docker Compose up, let's remove the Nginx container. Idea is that we do a clean start, and it's been removed. Now run Docker Compose up. Both the services running. Back to the browser, try hitting the registry catalog URL. Now it prompts for the basic auth credentials. I'll type in the one that I generated, admin and some password. Now that lets me in. Now this basic auth is going to be common between either you access it from the browser or using the Docker command line. Now back to the terminal. On a separate terminal session, let's create a new Docker machine on a VirtualBox locally. So create a machine using VirtualBox driver and name it as dev1. After a couple of minutes, we have a dev1 machine created. SSH onto dev1. I'll pull some Docker image from the Docker hub. Let me pick busybox. Docker pull busybox. The idea is to tag this and push the tagged image onto our private registry. Now list all the images. We have just one busybox. Let's have Docker log into our private registry. Use the admin user and the password that we have set before. The login is successful. Tag the busybox image for the private registry. List images. Now we have a copy or a new tag for busybox. Push this tag using Docker push, which will get that pushed onto our new private registry. On the browser, refresh and reload the catalog page. Now we have busybox in there. Notice there is an issue with this setup, is that if you delete the container, you will lose all the images on it. Let's take a look. Stop the services, remove the registry container, and then run Docker Compose up again. Reload the catalog page on the browser, and we lost the busybox repository that we just pushed. That's not good. Stop the services, remove the container again. Instead of the container, let the registry data be stored on the server or the Docker host. With that, even if we recreate the registry container multiple times, we won't lose the data. Create a data directory on the host, and in the Docker Compose YAML, under registry service, add a volume for the registry data directory. This volume will have read-write mode because the container will need to write into it. The services are already stopped. Run Docker Compose up again. Reload the catalog page. There are no repositories because the previous one was gone anyway. Back to the dev1 machine. Push the same image or the tag again. Reload the catalog page on the browser. Now we have the new busybox repository created. To verify the registry data not wiped out when the container is recreated, let's delete the registry container one more time. Need to stop the service before it can be deleted. Remove the registry container again. registry container is now gone. Run Docker Compose up again and reload the catalog page, and the busy box is still there. Let's take a quick look at the registry data directory on the server. SSH onto the server, go to /root/regdata directory, list and browse through the directory structure. You'll get an idea of how the repositories are getting stored. Storing the registry data on the file system of a VM, in this case our droplet, is also not recommended, but for some use cases it really works. I have a similar one which I use to store Docker images for quite a few applications. Another option is to use AWS S3, which is not in the scope of this video, but all that you need to do is follow the documentation and make a few changes in the Docker Compose file. That's it for this episode. Thanks for watching.